You got some appointments. All right, so 8.6b, that's what we're going to do. So remember, we learned, very first thing we learned is what rectangle. We're using a rectangle to figure out the area under the curve. And then we say, hey, it'll be a better way than a rectangle. So better way was what? Trapezoid. Are you with me? So now we're going to say, okay, I will show you even better than that. Okay, even better than that. That's called Simpsons rule. So Simpsons rule is using a quadratic function. All right, quadratic function. So this is just, I'm giving you theorem. I'm not proving this. If you have a quadratic equation, like a polynomial, the degree of 2, which is a quadratic equation, right? 2 function, 2 degree. Then you can do this polynomial. You can take polynomial, integrate it, this polynomial, any degree of 2 polynomial. Are you with me? Anything that's continuous function. You can do this. Instead of b minus over a divided by 6. Okay, this is part of the function. Are you with me?
And the capital B is the same as the lowercase.
Which what are you talking about? Is A, B, or
no, like so that A up there correlates to that. Oh, it's the latest.
Okay,
I got you.
This A and B. Not this A and B. This is a constant of A and C. Okay, with the these are the coefficients of x's. This smaller A and B is what your boundary, upper boundary, lower boundary. So you upper limit minus lower limit divided by 6, then you're going to do f of a plus 4p times a plus a plus b over 2 plus p over b. That is the formula for the quadratic equation. So we're using this. We're not going to do just the one. We're going to do what? 1, 2, 3, 4. Every one of them, every pieces. Okay, when you do that, Simpsons rule is getting this. Simpsons rule says if f is continuous with a and b. Okay, and let n be an even integer. So you have to use n to be even integer. You have to use even integers. Okay. The Simpsons rule, they're telling you gotta use even. All right, and equals even integer. Simpsons rule for the approximating integration from a to b of this function is what? They give you formula. So b minus a over n. Just remember this. B minus over n is just the what? Width. We have that all the time. Rectangle, you have a b minus a over n, which is the width. Trapezoid, you have what? B minus a over n, which is what? Width. That's just part of the formula. So the 1/3 came from just for the Simpsons rule. When you factor out, you get a 1/3. Are you with me, class? So that's 3 came from there. And then this is their formula. Their pattern is this. First one, the last one, you only count once. Copy, see the formula. So you can see my screen. So f of a and f of last one, what does that mean? This means when you count the area, you only count this once. And this count what? Once. The very beginning, you count only once. Very last one, you count only once. So what does this mean over here then? The f of the x1. The first rectangle, right? How many times you counted? 4 times. So because it's a polynomial, which is second degree, that they count they're doing
even. So it's just do it twice right here, twice right here.
Right. So I'm not proving this, but you need to understand mentally. Okay, I see a 4 means I'm counting the x1, the finding f of x1. That the y value, you do how many times? You count how many times? 4. What's this f of x2 means? You counting twice.
Ended with like x of l was like 10. Then up until x8, it'll still be twice.
Okay. And then is twice.
Yeah, and then
x8 is here twice. Yeah. x4 is twice. But the x1, x3,
and the x10
x5, right, you got it. So everybody see it? When the position is a odd position, you count it 4 times. When the position is even position, what do you do? Count what? Twice. When do you only count once? Beginning and then what? End. Okay. Alright. So let's do the problem. The exact same problem, the sign between 0 to pi. Because we want to see whether this is a better. Okay, is it better? Does it give you better solutions? Okay. So when n equals to 4, I use even number. Did you see that? N equals to 4. So now what I'm going to do what? So first thing you do what? define your function. All right. And then I'm going to define what? All the variables. What variables do I need to define? A equal to 0, and B equal to pi, and then what else? N equal to 4, and then I'm going to find what? My width. Width is always what? B minus A over what? N. That's mine. So I'm going to define all 4 of them. So shift enter. Okay, class. The last thing is the only thing Jupyter will spit out. Okay, even though this is all defined, this is the only thing spit out. Are you with me, class? All right, now what do you do? Well, this one you don't have to do, but I usually do my domain between 0 to there. You don't have to do this actually. I can take it out if I need. Now, what are we gonna do? Let's do one by one. Okay, until and the next we're gonna automate it. But the first one, let's understand the concept. Okay, concept. So I need to find what? F of 0. So I'm gonna say f of a is my f of 0. What's next one? F of 1. How do you find f of 1? A plus 1. 1 with, right? 1 with, but I didn't do 1 because 1 times W1 is W1, right? So I do that. Okay, now next one will be what? Find which one? F2, not the height, right? F2, what do you do? A plus what? 2 times W1. Okay, so let's do that. That's that. What's next one? The next column, right? Next one should be F3 and F4. I'm done. Because n equal to 4, so I can finish it well. N equal to 4, which is F4. So actually, you're doing 5 of them, right? You're calculating 5. 0 to 4 should be 0, 1, 2, 3, 4. So it'll be 5 of them you calculate. Okay, now what's the formula? The formula is what? T minus A over 40N, or T minus A over N is same as what? W1?
No, that's the same.
Divided by what? 3. Remember? T minus N over N is same as what? W. Are you following? Remember you defined that right here? W1 is same as what? T minus A over 1. I mean to say what? N. So T minus A over 1. And is your W. Are you with me? So I can just replace T minus A over N with W. Are you following me? So I put area and when N equal to 4, what do you have? W1 divided by 3. This 3 came from what? Part of the formula. Remember this formula, the 3 underneath, right? Now what do you do? Very first one I count 1. The second one I count what? 4 times. And the next one will be what? 2 times. The next one will be what? 4 times. The last one you will do what? 1 time. So enter that. So your area is 2.0045.
So was the Simpsons rule more accurate than the Trevor?
Yes, that's what I'm trying to show you. So the real solution is what? 2.0.
Only when you use the quadratic though?
But quadratic is always better than linear. But when you get very, very small, you cannot see the difference. All right, so looking at this, remember? The Simpsons rule you got 2.0 with n equal to 4. But the trapezoid, what did you get? 1.89. So you can see it. If you just do 4 times,
it's way more accurate.
The partition is only 4 partitions. Simpsons will give you much better estimation. Did you see that? You literally see it yourself. Okay, now, you know we're not going to do this. When n equal to 1,000, I cannot do 1 by 1. That's too many. So let's talk about how we're going to do this. So this is what I wrote. Okay, that does not mean this is the only way. Are you with me, class? This is one way that you can do, because this is what I wrote. If you search it in a Google, there's other people use the Simpsons rule in a different way than I did. Okay, this is the one way that I did. The function Simpsons rule takes how many arguments? 4. F is my function that I'm going to use. A is what? The lower limit, right? What's B? Upper limit. What is N? How many partitions you're going to make, right? Are you All good. What's the next one? Let's define something that I need. What is it? I need a width. How do you find the width of your partition? B minus over A over N. That does not change, right? That's what I use for the rectangle. That's what I use for trapezoid. That's what I use for what? Simpsons rule. Like this Friday, I'm going to give a different method. Are you with me? I'm not giving you trapezoid. I'm not giving you Simpsons rule. I'm going to give you a different method. You gotta look at the different method, and then you don't have to write function. If you want to, I give extra points. But if you want to do step by step, you can do that. Okay, because I'm only going to give you n equal to 4. So if you choose to do one by one, you can do that. Right? But if you choose to write a program during that on 1 hour, I'll definitely give you extra points. Okay. All right. So area equal to 0. That's what am I doing? It's called initializing. Okay. I'm initializing area equal to 0. So I'm starting with area to be nothing, just a 0. Okay. Because after that, I'm going to keep adding into area. All right. So let's do my for loop. 4 is what I in starting with the 1 goes all the way to what? N minus 1. Remember, I don't count the last one. I don't count the very first ones. I don't count x0. I don't count what? x4. I only count what? x1, x2, x3. Are you with me, class? So that's why you do n minus 1. Is everybody with me? So far, so good? Anybody lost? Okay, are you with me? Okay. Now, remember your formula? You have, when the partition is odd number, you multiply by what? 4. When partition is even number, what do?
2.
Multiply by 2. So I need to separate it. How can I separate it? What statement do I have to use? That's called what? If. Are you with me? When you want to separate it, you have to give condition. If, what do? If I is in what? It's odd number. Look at this. I'm incrementing by what? 2's. So it'll be 1. Next one will be what? 3. What's next one? 5. What's next one? 7. What's next one? 9. So I wrote it like this. I don't know how to say odd. Okay, I didn't know how to say and like a sum. Sum.
They use the modular operator. Yeah.
That's wrong.
Get the remainder.
That's what I'm saying. Use that then. You can use a mod. Right, that's fine. If you want to use a mod.
Is that percent sign?
Yes, I think so. So if you choose to use that, that's fine. I just said this is a one way. I thought about it right away. Because I did equal to odd. And then said Julia does not know what odd means. So I couldn't use odd. So I said, okay, how can I define odd in different ways?
If odd divided by 2 is equal to 0, then it's even. If it's equal to 1, it's odd.
Right, so you can do it. Yes. So did you see that? That's another way you can do it. So anyway, I chose to do this way. That's the way I'm going to find my odd number. I'll say I will increment by what? 2's. 1, 3, 5, 7, 9. So that's what I did. All right. So if this is odd, what I'm going to do? The initialized area plus what? 4 times of that. A plus IW. Are you with me, class? So I is the only odd number. 1, 3, 5, 7, 9, so on and so forth. Okay. All right. If I is not an odd number, where do I go? I go to where?
Else, that means the guy.
Else, which means automatically this means what? Even number. So if it's an even number, what do? Multiply by what? 2. So I'm done. So when you study with the if, you gotta end it with a end sign. Okay? And with me, class, that's the format. If starts with the if, then it ends with what? End. Okay, now same thing with what? 4 has to start with what? Starts with the 4, so we're ending with the what? End. All right, all the calculations done in here is for loop. So what's my total area? Total area would be what? W over 3 times what? First one, the last one plus what? In the middle. And then you will end it. Does everybody understand this program? All right, let's try the 4 one. You get the same number, right? When it's 8, then I'll change what? I change everything same except what? Okay, so now let's look at the errors. 0.0000, which is very good. It's less than 0.02%, okay, which is very good. It's very good, very good. So now let's try n equal to 500. Practically same. Look at how many zeros you have. So when you look at the errors, you got what? 0 to the 11th, something to negative 11th. That means about how many zeros you have in the front? 10 of them. 0 to 0, 0, 0 to 10 zeros in the front. The 11th position, you have what? 1. So which means practically same. Okay? To me, like after 4 zeros, it's practically same to me. Okay, so less than 0.01%. All right, so what can you say? When n gets larger, what can you say? The numerical solution gets what? Close to true solution.